Hello, everybody. Welcome to this lesson on quadratic applications. This is basically going to be doing word problems using quadratics and our knowledge of the equations and the graphs. I want you to know that there is a handout that goes along with this. It's called 4.1 Quadratic Applications handout. And what I want you to know that there are four problems, but two of each type. And so the first problem of each section I'm going to do together in the video here. And the second one is for practice for you. And then the same with the second part, I'm going to do the first one and then you're going to try the second one. I will post the solutions for all four problems. Okay, so let's go ahead and get in here. Our learning goal for today then is to solve word problems involving quadratic equations. And the first type of application is when we're given a graph and what information we can get from the graph. So let's say we have Justin here. He's standing on a cliff that's 16 feet high. So on our graph here, the x-axis you can think as the ground, and the y-axis is the cliff. Okay, and each one of these measurements are in feet because we're told he's at 16 feet. So he's going to be standing here on the cliff at 16 feet. He throws a rock into the air and it follows this path and then hits the ground down here. This is vertical distance starting from 0 at the bottom and goes up, and horizontal distance starts at 0 at the cliff and goes to the right. So this is broken down into a few questions. So the first one is state the vertex. What does it represent in this situation? Well, remember the vertex is the highest or lowest point of a parabola. So here it's going to be about here, which is 3 and 25. So the point, remember you always put your x coordinate first and then your y value. In this situation, that's the highest point that the rock reaches. If you take physics, you'll know that this is where the rock changes direction and it stops. It has a velocity of 0 right there. Okay, so that's part A. So part B, what is the y-intercept and what does that mean? Well, the y-intercept is where the graph intersects the y-axis, and that's when x is 0 and y is 16, and that's where the stone starts from. Okay, next question. State the 0 or the x-intercept. What does it represent? So the x-intercept is where the graph intersects the x-axis, and that happens when x is 8 and y is 0, and that's where the stone lands on the ground. Okay, next question. Add the axis of symmetry to the graph. So remember, the axis of symmetry is a vertical line that goes right through the vertex. So remember, our vertex was at 3 and 25. So we're going to draw a vertical line that goes through x equals 3, just like that. And that's the line that splits the parabola in half so that it's symmetrical on both sides. So now we're going to use this axis of symmetry to find the other 0. Well, how do we do that? Well, because the axis of symmetry is halfway between the two zeros, we can use the distance between the axis of symmetry and the x-intercept to find the other one. So from the axis of symmetry to this x-intercept, it is 1, 2, 3, 4, 5 feet. So now we're going to go 5 in the other direction to find where the other 0 would be. 1, 2, 3, 4, 5, which is at -2. So you can imagine if you continued this parabola down, it would cross the x-axis at -2. So that's where the other 0 will be, at -2 and 0. Okay, so determine the equation of the graph in the form y equals a times x minus r times x minus s. Remember, r and s are our two zeros. Well, we just found our zeros. One is 8 and one is -2. So we're going to plop them in for r and s. Now for a, you might notice that it's a negative facing, it's a downward facing parabola. So a is going to be -1. So a is -1. We're going to put -2 in for r and 8 in for s. It doesn't matter which order you put them in, by the way. Because this is subtracting a negative number, we can clean that up and we can kind of take this 1 out of here to clean it up a bit more. So the equation is y equals negative x plus 2 times x minus 8. The next question is, can we determine the equation in this form, in our standard form? Well, you might remember we can go from, what's that form? Factored form. We can go from factored form to standard form by expanding, so by multiplying. So we have this equation. We're going to multiply these through to get it into this form. So you can do it in any order, but I'm going to multiply the two binomials first. So using my FOIL idea, or if you want to use the area model, you can. X times x is x squared. 2 times x is 2x. X times -8 is -8x. And 2 times -8 is -16. We can combine these two in the middle because remember, you're going to collect your like terms. So that gives us negative times x squared minus 6x minus 16. And now we need to distribute this negative sign into each term. So the final equation is negative x squared plus 6x plus 16. Okay, so that's it for that type of problem where you're given in a graph and are asked to find information using the graph. The second example I'm going to do is when you're giving information and you might have to make a graph and then get um, additional information from that. So this time we have a ball that's thrown from 5 meters, reaches a maximum height of 9 meters after 2 seconds, and lands after 5 seconds. So the first question is to sketch a quadratic graph, and we need to include the axis of symmetry. So on your page, I've given you a coordinate grid that looks like this, where we have height in meters along the y-axis and time in seconds along the x-axis. So a ball is thrown at 5 meters, which means it start at 5 meters. Remember, starting time is always going to be 0. We are not working with negative time in this class right now. So our first point will then be time 0, height is 5. So we're going to place our point there. Then it says it reaches a maximum height of 9 meters after 2 seconds. So that gives us a point. After 2 seconds, the height is 9 meters, so we can plot a point there. And then after 5 seconds, it lands. Well, 5 seconds in here. And what does that mean where it lands? Well, it means the height is 0. So there's our third point. And now we're going to do a rough sketch. Mine is very rough. Don't make fun of me. But you know, it is what it is. Try to do it as nice as you can. Remember, the axis of symmetry is a vertical line that goes right through the vertex, which is our maximum point. So we're going to draw a vertical line when x is 2. Okay, what's the next question? Now that we have a graph, fill in the table. So we're going to use either this information or a graph to fill in this table. So the y-intercept, that's when y is 5 and x is 0. The vertex is this point here, so 2 and 9. The 0 or x-intercept, that's when x is 5 and y is 0. Now, to find this other point, remember we can use the idea that our points are symmetric about the axis of symmetry. So if I look here, my 5 is 1, 2, 3 away from my axis of symmetry. So if I go 1, 2, 3 to the left, x is going to be -1. And so that becomes my other 0. Great, so now that we have that, we can now find our equation in the form of a times x minus r times x minus s. So your a is going to be -1, just like the last one. Our two zeros were -1 and 5. And now we're going to clean this up a little bit because if we're subtracting 1, that's going to become x plus 1, but don't forget to bring that negative sign down. So there is our equation in factored form for this parabola that models this situation. Let's see what's next. So now using our equation, what is the height of the ball at 1 second and 3 seconds? So at 1 second, we're going to put in if I go back, we're going to put in x is 1 for 1 second. So at 1 second, we're going to replace our x's with 1's. So 1 plus 1 for the first bracket is 2, and 1 minus 5 is -4. But don't forget that you have this negative sign in front. So you're going to do -1 times 2 times -4 gives you 8 meters. And then at 3 seconds, you're going to replace your x values with 3 instead of with 1. So at 3 seconds, we've got 3 plus 1 is 4, and 3 minus 5 is -2, and we got a negative out in front. So -4 times -2 is +8 meters. The reason why we want to use the equation, if possible, to find these types of values, because look at my graph. If I looked at when my ball is at 1 second, I would say the first one was 8, but at 3, I would say it's at about 7, right? Because I didn't draw this very nicely. So to get a very precise number for our answers, we can use the equations. So that is D. Now take a look at those answers. What did you notice? They were the same, right? They were both 8. And that kind of makes sense because they are equal horizontal distance from the axis of symmetry. Remember, um, for a parabola, our points are going to be symmetrical on either side. So because I'm 1 second to the left and it's 8, if I'm 1 second to the right from the axis of symmetry, it should also be 8. And you can use that to find symmetrical points on any side. So that's it for today's lesson. So you can go ahead and try the second questions on the 4.1 handout on Brightspace. For more additional practice, there is more practice like this for day number 3 in the cycle 4 practice booklet. There is answers for the first page. I wouldn't do any more than the first page. So you can go ahead and try this out. Once you feel comfortable, go ahead and try the 4.1 quiz. If you have any questions, please let me know using the envelope icon in the top right-hand corner of Brightspace. See you next time. Bye-bye.